Hi, welcome back to my channel. And for today's video, we will be talking about permutation. So this is actually in response to everyone who messaged me sincerely that they are asking for help on how to solve for a permutation problem and assignments at school. So thank you so much for reaching me. And I just so you know, I don't have to answer your assignments. You'll be the one to answer that. What I can do here is to teach you on how to answer that. And also to explain you further that this is the best way or this is the best method in order for us to deal with such problem. Okay, so what is permutation? So permutation is the rearrangement of objects or just an arrangement of objects. So that that is. So just wanna be clear because we can encounter a lot of notations for permutations. So say for example it could be in a cycle order wherein you have 1, 2, 3, 4, 5 and you'd have something like this. So that's a permutation. However, in this video we are focusing here is the idea that we don't have to rearrange objects, but we are actually solving for the number of ways an object can be I mean a set of objects can be rearranged. So this is the goal of the video. So basically we are doing with a basic statistics here. So in order for us to know the number of ways an object can be rearranged is given by this formula. So you have a permutation of n taken r at a time. So that's equivalent to n factorial over n minus r factorial. So in this case, n is the cardinality of the set at which this is being permuted. So r here is the size of permutation. And of course, we should know that n and r here is greater than or equal to 0. And provided that n is always greater than or equal to r. Okay. Now, what does this factorial mean? So let's review for our factorial here. So n factorial, that implies to you have to multiply the number by the preceding numbers up until it goes to 1. So here, n times n minus 1 times n minus 2 until 2 times 1. So basically, if you have, let's say, 5 factorial, that means that's equivalent to 5 times 4 times 3 times 2 times 1. That's it. Okay. Now, for this specific number of ways on rearranging an object, since we are only focusing here in this video for the number of ways to rearrange the object. So this is a dummy representation formula. So I don't know in other books how do they write their symbols, but basically this is of course undisputed formula. So that means it's you have n factorial over n minus r quantity factorial. So technically, as long as you know that n here is the size of, I mean, is the cardinality of the set at which you are aiming to permute that one, and r is the size of permutation. So that's the important thing there. So let's consider here an example. What is what is p of 5 4? So that means permutation of 5 objects taken 4 at a time. So in this case, our n here is 5, our r here is 4. So by virtue of the formula, you have n factorial over n minus 4 n minus r factorial. So this is 5 factorial over 5 minus 4 factorial. So this is just 1 factorial here, and 1 factorial is 1. So basically you have a denominator 1. So you can have 5 factorial, that's 5 times 4 times 3 times 2 times 1. And so you get a total of, how much is this? I guess this is 120. Yeah, so that there are 120 ways to arrange this one. Okay, that's it. Okay, so we before we proceed further, I just have to give a remark that we have to remember. Number one remark is 1 factorial is equal to 1 because 1 factorial is just 1. 1 times 1 so on and so on. And number 2, 0 factorial is always 1. So that's the rule. Okay, so we have identity that we have also to remember. Number 1 is P of n here. So this is if you have to solve that P of n here, that's equivalent to n factorial over n minus n factorial, because your r here is n. So this is actually 1 here is r. So you'd have n factorial over 0 factorial. 0 factorial is 1, so you'll get n factorial. So therefore, P of nn is actually n factorial. So that's the first identity here. Another identity is, suppose you have n1. So n1 here, if you notice, that's n factorial over n minus 1 factorial. Note that n factorial can be written as n times n minus 1 times n minus 2 up until 2 times 1. And starting from n minus 1 going to 1, this is equivalent to n minus 1 factorial, right? So I can have n times n minus 1 factorial over n minus 1 factorial. So this will be canceled. So you left with n. So therefore, P of n1 is actually n. So these are the formulas that you have to remember. So these are actually basic that you ought to remember for you to be able to master these identities and solving the number of ways arranging an objects. Okay, so let's consider example. Let's say example 1. What is P of 6, 6? So by virtue of the formula number 1 here, that's n, so that means it's 6, 6. So they have this n and r here is equal. So automatically you have 6 factorial. So that's equivalent to 6 times 5 times 4 times 3 times 2 times 1. And so you get, I think, 720 if my calculation is correct. That's it. Okay, so let's try another example here. So I have P of n3. That's equal to 60. So observe that P of n3, I can write this as n factorial over n minus 3 factorial. That's equal to 60. Okay. And I can write n factorial here as n times n minus 1 times n minus 2 times n minus 3 factorial all over n minus 3 factorial, and that's equal to 60. So I will cancel this one here, and so I'd left with n minus 1, n minus 2 equals 60. Okay, so that means you're looking for 3 consecutive integers with the product 60. So can we think of three consecutive integers? So I guess this is 5 here, this is 4 here, and this is 3. If you multiply these three things here, that means 5 times 4, that's 20, times 3, you get 60. So therefore, your n is 5. So let's take a review on that. So let's recheck. What is P of 5, 3? So that's P of 5, 3, that's 5 factorial over 5 minus 3, that's 2 factorial. So basically, you have 5 times 4 times 3 times 2 factorial over 2 factorial, so that will be canceled. 5 times 4 times 3, you get 60. So therefore, n here is 5. So the answer here is n equals 5. That's it. So if you have questions or clarification, you can comment down there, or you can request on the comment section for a specific topic you would like me to discuss. Again, thank you so much for those who messaged me on asking if the video that I will be presenting will be this one here. Okay, so let's consider another example here. How many possible ways can three cards from a deck of cards be selected and given to three players? So basically you have, I think, 52 cards in total. Yeah, 52 cards, because there are four different types. I mean, how they call that? Like flowers or so on. Like there's an ace, there's a diamond, there's a heart, and there's the other one. I don't know. Okay, so there are 54 cards in total, and you are actually you're asking if how many possible ways can three cards be selected from those 52 cards and given to three players. So this is actually a rearrangement, because you're rearranging possible items for you to get three cards to be given to three players. So basically you have P of 52, 3. That's it, and you'll be the one to compute that. So if you have any questions or clarifications, you can comment down there and discuss whatever would be the possible problems that you would encounter. And that's all. Okay, so we will consider one final example here. So there are 7 boys and 3 girls in gathering. In how many ways can they be rearranged in a row so that number 1, 3 girls form a single block. Number 2, two end positions are occupied by boys and no girls are adjacent. So let's focus first on letter A. So there are 7 boys and there are 3 girls. But it says here that 3 girls form a single block. So regardless of what happened, these 3 girls will be considered as one entity here. So since that will be considered as one entity, so that means there are a total. So this is actually 1 in this case. So 7 boys and 1 entity. So that means you just have to imagine that 3 girls will be represented by 1 person. So that means a total of 8 entities. So that means 8 factorial. However, for those 3 girls that will form an entity, they can rearrange themselves. Whether let's say this is A, B, C represents 4 girls. You can arrange them like A, C, B, or A, B, C, or B, A, C, and so on. So that means you can multiply that by 3 factorial. So therefore, for letter A, that is 8 factorial times 3 factorial. And then you simplify, and that will be the number of ways to rearrange 7 boys and 3 girls such that 3 girls form a single block. That's it. Okay, so let's consider for letter B. Okay, for letter B, in this case, there are 7 boys. So what are we gonna do on how to attack this problem is that you have to make sure that the two end positions of the arrangement are occupied by boys. So which means that you have to rearrange the boys first. So there are 7 ways to rearrange the boys because there are 7 boys, so that's 7 factorial. Now, if you're gonna rearrange the boys, let's say this is boy number 1, 2, 3, 4, 5, 6. I'm sorry, 6, 7. So therefore, the spaces for girls are this one in between of those numbers. But you cannot place the girl before the first boy and the last boy because again, according to the rule, the two end positions shall be occupied by boys. So these are the endpoints here. So these positions are occupied already by boys. So therefore, the selections for girls are on this one only in between the boys. And also, you cannot put I mean, you cannot select selections for girls such that they will be adjacent because it says here that no girls are adjacent. So no girls shall be together in a certain place. So if a girl is placed here, you cannot put another girl here. So you can go only for the other spaces. So there are three girls. So let's say you have A, B, C girls. So for A, she can choose out of six, right? Okay, so there are six spaces. So since there are six spaces, that means you can multiply this by six options for girls. So in this case, we are only considering one case scenario and then we multiply that by the number of permutations. Another for let okay, so suppose for example for the girl number A, so that's first girl it has already chosen this one. So how many remaining spaces the second girl can choose? So you have 1, 2, 3, 4, 5. So that means the second can choose 5. And lastly, the third can choose 4. So therefore, the number of ways to rearrange these persons is 7 factorial times 6 times 5 times 4. And that's it. So if you have any questions or clarifications, you can comment down there. And for those who are new to my channel, you can click on subscribe for you to be updated on another topic that I will be discussing based on your online classes problem. Okay, thank you so much for now. So that's all. The purpose of this video is only to explain to you on how to compute the number of ways to rearrange objects. So we're not technically rearranging objects because that's another topic for permutation. So if you have questions or clarifications, you can comment down there. And you can request as well if you have any clarifications for a certain topic in your online class. So thank you so much for watching and have a great day to you all. Bye for now.